Imagine you're working with a massive spreadsheet and your boss asks you to sum up sales for a specific product, but only if it meets certain criteria. Oh, and they need it in the next 10 minutes. Most Excel users would immediately reach for SUMIFS or PivotTables, but what if I told you there's a better way? Database functions are little-known gems that handle complex criteria effortlessly, and they're not hindered by the limitations of SUMIFS and the other ifs functions. Okay, let's start with the dsum function, which sums up data based on criteria you specify. The syntax is fairly straightforward. It wants to know where the data is, what field or columns you want to sum, and what the filter criteria is. Easy. The data I'm using to demonstrate is a list of invoices by type, date, name, and amount. You can see it's formatted in an Excel table called Data Table. Let's say I want to sum the amounts for all level 1 invoices. Unlike SUMIFS, the criteria are set out in a table. For this, we need to specify the column name that the filter criteria belongs to, which is type. And then I simply list my criteria. So I want all level 1 invoices, and then equals dsum, tab. The database, that's my table of data, including the heading. Now remember, my data's in a table, so we get the table name followed by #all. But if your data's not formatted in a table, then you'll enter the cell references here. Next, we have the field that we want to sum. That is the name of the field, and that's the amount field. And lastly, the criteria, which are in these cells here. Let me F4 to absolute the reference on the criteria, and Control Enter, and we get 102,000. Now once you know one database function, the others are easy. So let me copy this across, and then we'll just edit the function here to return the other examples. So we want average, max, and dmin. And because the criteria are in cells in the worksheet, it's super easy to link it to a drop-down list and allow your user to change the level that's been returned by the database functions. Okay, they were some easy examples. Next, let's look at multiple criteria, including how we can overcome the limitations of the SUMIFS and other ifs functions, which can't handle all criteria. We'll start with multiple and criteria. For example, let's say we want to sum level 1 invoices with dates between January and March 2021. Again, we're filtering based on the type, and the type is level 1. And then the next criteria will be a date. So we need the date as the heading, and I want dates that are greater than or equal to the 1st of January 2021. And then my next criteria is also a date, so we enter the date column again, and this is less than or equal to 31st of March 2021. Now my dates are formatted day, month, year, so they may look a little wonky to you. Now I can write my dsum formula. Again, the database is the whole table, including the headers. The field is the amount column, and the criteria are the cells, including the headings. Close parentheses on dsum, and it returns 38,000. Now you notice the other database functions were returned at the same time. It's not sorcery. I just had some conditional formatting on those cells, so they only appear when I finish the dsum formula. The main limitation of the ifs functions is they only work with AND criteria. That is, they only include rows where all criteria are met. If you want to include rows where all criteria don't need to be met, for example, where invoices are level 1 or level 2, then you have to daisy chain them together, which is very inefficient. But database functions can handle this with ease. Again, name the column that you want to filter by. In this case, it's type. And then list the criteria down the rows. So level 1 and level 2 equals dsum. The database is the table, including the headings. The field is the amount column. And the criteria are the type, level 1 and level 2. Close parentheses. And it returns 322242. And again, we've got dcount, daverage, dmax, and dmin as well. Let's look at how we can combine multiple and or criteria. Here I want to sum the amounts where the type is level 1 and the date is greater than or equal to the 1st of January 2021 and less than or equal to the 31st of March 2021, or where the type is level 2 with the same date range. In other words, the criteria going across the row are treated as AND. That is, they all must be met for an amount to be included in the sum. And then going down the spreadsheet, the criteria are treated as OR. That is, if a row contains level 1 or level 2, and the dates are greater than or equal to the 1st of January, and less than or equal to the 31st of March 2021, then those rows will be included in my dsum. Equals dsum. The database, again, is my table. The field I want to sum is the amount column, and these are my criteria. Close parentheses, and we get 229151. Again, we can use this criteria with dcount, daverage, dmax, and dmin, etc. Not only can the database functions get around the limitations of the ifs functions, the criteria table also makes it easy to see exactly what's included in the calculation. I know all this flexibility can be confusing, so let's look at another scenario you might come across. But first, if you're finding these Excel functions useful and you want to take your skills even further, check out my Advanced Excel Formulas course. It's packed with all the functions that will save you hours of work and help you stand out. And what's great about this course is it doesn't just cover the basics. It dives into real-world examples with quick, bite-sized videos showing you both the fundamentals and more advanced, less obvious uses. Once you're done, you'll have a solid understanding of how to create robust formulas that enable you to handle any scenario. I've also got other courses on Excel and Power BI, and you'll find all the details in the description and pinned comment below. Okay, let's say you want to sum amounts where the type is level 1 or the name is not Atkins. When specifying multiple OR criteria for different fields, it can be a little mind-bending. For example, here we'll aggregate all data which is for level 1 for all names, because the name field is blank on the first criteria row, plus all levels where the name is not Atkins, because the type field is blank on the second criteria row. So let's equals dsum, the database, again including the headers. The field I want to sum is amount, and the criteria is in this table here. Those parentheses, and we get 1129097. Now I've got a pivot table below with the amounts by name and level, so we can just validate what's included in this dsum formula. So remember, we've got all of level 1, that's 102,000, and then we've got all levels where the name is not Atkins. So Atkins is here, we've just got one other amount of 3,000. So holding down Control, I'm just going to select all the other cells for the remaining levels. So I've got all of level 1 selected, and the remaining levels excluding Atkins, and Arthur doesn't have any values other than for level 1. And if we look down in the status bar, you can see the sum is the same, 1129097. So we can see exactly how the criteria are specifying what dsum includes. All right, let's look at some other cool tricks. For example, database functions can also handle wildcards. Here I want to aggregate all data where the names begin with B. So B asterisk equals dsum, the database including the headers. Now here, I don't have to specify the field argument by naming the column. I can simply use the column number. So in this case, the amount column is 1, 2, 3, 4, 5. It's the 5th column, and the criteria is here. Close parentheses, and we get 367349. And notice we can use the number column in the other database functions as well. Unlike the other database functions which aggregate data, the DGET function is the odd one out because it only returns a single value. For example, we can use it to look up an invoice number, in this case invoice number 603, and return the amount. So DGET, the database is here including the headers. The field, well, I want to return the amount, so that's the 5th field. And the criteria is the invoice column, invoice number 603. Close parentheses, and you can see it returns 4,000. There's invoice 603, and there's the amount. This is effectively the same as an XLOOKUP or VLOOKUP formula. However, if your result returns more than one matching record, DGET will return a num error. So let's just take a look. If I want to get the amount, which is the 5th column, for type level 1, well, we've got lots of level 1 invoices. I'll close parentheses, therefore we get the num error because DGET doesn't know which invoice you want the amount returned for. Whereas if you used VLOOKUP or XLOOKUP, they would simply return the first amount they find. If you found these Excel tricks helpful, you're going to love this video that covers 10 powerful formulas that'll make you stand out at work. Trust me, your spreadsheets will never be the same. I'll see you there.